material handling machines, several parameters can be looked at, such as the material flow rate, segregation, and also potential areas of wear. In this slide, we have an example of a transfer chute with a rock box. Some of the analysis that can be done with Eden includes looking at material velocity and segregation. So you can simulate and compare the behavior of different types of material. For example, in this video, we can see non-cohesive material and cohesive and see how that affects the flow and the equipment. You can also track data by using virtual sensors. For example, mass flow in a particular region and determine the total mass and segregation, as this video is showing. But also you can determine the dynamic mass distribution. So that can be visualized and showing, in this case, the difference of 10% between the right and left sides. And finally, wear analysis. That can be performed and is very important area, as we can see where part of the equipment have been affected. Now, in this slide, we are showing a screwdriver video, which a range of parameters that can be analyzed. For example, handling capacity. That is an indicator to measure production capacity of a screw conveyor. However, it is also closely related to other parameters, such as a screw blade rotation speed, that has great effect on handling capacity. Another parameter is the screw blade diameter, as it is directly related to the capacity and equipment dimensions. We also have the screw pitch. This not only decides the lead angle of the screwdriver, but also decides the split surface of the material under certain filling coefficients. And finally, you can vary the inclination angle of the screw conveyor that has an influence on the productivity and power consumption. So other points of analysis include wear of the auger, forces on the screw, and forces of particles on the surface that they fall on, for example, a hopper. Here at the top, we have a slow motion visual analysis. At the bottom, we have two graphs representing two parameters. One is the screw blade power, and the second one, the mass flow rate. So because the amount of material being pushed by the screw changed during the simulation, the power observed is very changeable. So please note that this simulation is scaled down, and that's why the power values are very small. Also, the graph on the right shows the mass flow rate, and as expected, the material comes out in gouges and decreases exponentially as the material is pushed out. All this information will allow us to study the equipment design. So for instance, to estimate how much power the motor needs to have to drive the screw. This will vary for different materials, which can be individually simulated and compared. Here we have another example, and this is a bucket elevator. It is used in several applications, such as unloading river barges, and also for reclaiming material from stockpiles. Some areas of analysis are, for instance, assessing the efficiency of the elevator. So, for example, the maximum feed flow rate, the maximum output flow rate, and the influence of the shape of the bucket are some of the analysis that can be conducted. So in the previous video, there was an undesired operational issue that was happening, and that was that the material spillage, as the bucket traveled outwards, and also spillage at the outlet. So Eden analysis option can be determined that only 50% of the material that is fed reach the top of the elevator. But because of further spillage, only 40% of the material fed actually reach the outlet. So this current elevator design will result in a buildup of material at the bottom, which may lead to clogging, poor performance, also potentially failure. So the slow motion view of the process allows us to understand that is the shape of the bucket that is preventing the whole material to flow out, as we can see in the image at the bottom. So a new design that is suggested on the right bottom corner could potentially resolve the spillage issue by being convex towards the rim. So what we want to show here is that by running different simulation and different cases, a new design would allow to study and improve a better option and design for a specific case.